This continues the addition property of equality to solve algebraic expressions or equations in section 4.3. We're going to finish this last example that we got cut off, and we are then going to check all of the examples we have just done. So 3 plus 9 is going to give us 12. And that is equal to x plus 0, which is x, and negative 9 and positive 9, which is equal to 0, and we're not going to write that. And so there we have our solution, that x is equal to 12, or it says 12 is equal to x, but 12 being equal to x is exactly the same thing as x is equal to 12, because the equal sign has a property called the reflexive property, which is kind of like the commutative property. So now we're going to go ahead and we're going to check all of our solutions. So our first part, our part B here, we're going to check our solution by plugging in the value that we got for x, which was 1 1/4, which comes back to 5/4, and then building the higher term, we would end up back at 10/8. So we have 10/8 minus 7/8, and we're asking, is 10/8 minus 7/8, is that really equal to 3/8? And 10 minus 7, which is equal to 3, and those are 8s, and that does equal 3/8, and that forms our check. A check should always look like substitute in, find the values on each side of the equal sign, and show that they are a true statement. Our next one, we have again, what's our value? Negative 2.23 plus 3.5, and we're asking on this one, are we going to get the 1.27? Now remember, these kind of expressions are really silly when we work them at this level, but it's really important for us to actually learn the process for doing a check, even when the answer is pretty straightforward and we see that that's truly the answer. So I'm going to have to borrow here, and 10 minus 3, which is 7, 4 minus 2, which is 2, decimal comes down, 3 minus 2, which is 1, and the bigger number is positive, so this is going to be a positive. 1.27 is equal to 1.27, and therefore we do indeed have a check. The next one, we have 3 times our x value, which is 9, and we're asking, is that equal to 2 times 9 plus 9 more? 3 times 9 is 27, and we're asking, is that equal to 2 times 9, which is 18, and 18 plus 9? So 27, is that equal to 27? And yes, indeed it is, and so we see we have our check. Part E, we have a little bit more difficulty still. 3 times whatever we say that x is equal to, plus 9, is that equal to 2 times a negative 13, and then subtract 4. So 3 times negative 13 is a negative 39, and then plus a positive 9. 39 minus 9 is 30, and then it's negative. And we're asking still, is this equal to 2 times negative 13, which is a negative 26, plus a negative 4, and 26 plus 4, which is equal to 30, and of course it's a negative, and so we see that that's a check. And then our next problem, our part F, we see 4 times whatever our value of x is, that's our 12, plus 3, is that equal to 5 times whatever our value of x is, that's 12, minus 9. So 4 times 12 is 48, plus 3. 48 plus 3 is equal to 51, and then we're asking, is this equal to 5 times 12, which is equal to 60, minus 9, and 60 minus 9 is indeed 51, and 51 equals 51, which shows us that that is a check. So those are the checks for all of the problems that we did, and that of course was example number 19 in our notes here to do all of the checks. All right, we'll see you in the next for the multiplication property.